So here is the solution of problem number 20, which has been recorded. So let's go down to problem number 21. It says here that the triangle ABC is divided up into 4 regions by 3 lines parallel to BC. So let's just draw that. So you got triangle ABC. So it is divided into 4 regions by 3 lines which are parallel to BC. So let's just give names to this. We'll call it A, B, and C. The line AB is divided into 4 equal line segments. So this is AB. So let's just make them 4 equal line segments. And then you got all these parallel lines. All these lines are parallel to BC. Okay, if the second largest region has area 225, we can see what the second largest region is. This one here. What is the area of the whole triangle? Okay, now there's an important result here which we will need. It's about similar triangles, which by now I'm sure you will know what these. If you got 2 triangles are similar, if they've got the same angles, and then when the triangles are similar, the sides are in proportion. In other words, if the sides of this triangle, these angles are the same, then their triangles are said to be similar, and then the sides are in proportion. In other words, if this is ABC, then this is KA, KB, and KC, which is the same as saying that the ratio of the corresponding sides, this over this is K, KA over A, is the same as this over this, same as that over that. But with parallel lines, you have this thing becomes quite clear. With parallel lines, you've got 2 triangles which are created, a small triangle and a big triangle. And so if I take any line parallel, then you can see the small triangle is similar to the big triangle. It's got the same angles because you've got the 2 of the small angles are correspond to the small angle, this one and this one, they are equal, and this are equal. So you got these 2 triangles that have got the same angles. So you have that this triangle is similar to that triangle. So, which means that if you call the sides of the small triangle A and B, like that, then this whole thing is KA, and this whole thing is KB. Because those are this side here corresponds to that one. Both of them are opposite the cross angle. Similarly, this B and this is opposite the curl angle. Okay, so if you know those two, you have know those two. And in this case, they are given that this is, all these are equal. I'm not going to give any names to them, but you know they are equal. And therefore, if I call this A, right, you can see the ratio. This over this, that's your Ka over K. This over this is 2. So therefore, this will be 2A. Now, likewise, this and that is 3 now, because you got 3 parts. That over that is 3. So therefore, if this is A, this will be 3A. I just want to take this 225 out. We'll come back to that. So this is 3A. And likewise, this whole thing over this piece is 4. It's 4 times that. So this will be 4A. Okay, so the sides of these triangles are A, 2A, 3A, and 4A. Okay. Now, this whole thing is about areas. So we know the areas of these triangles, but we need to know about the heights. Let's have a look at the heights. When I draw the height of this triangle, I can draw one perpendicular. And because these lines are parallel, you get all these are 90 degrees. So so you know the heights of these triangles. Each of the triangles. Let's call this one small triangle this H. Then all these will be the same. This will be H, this will be H, and that will be H. Okay. Now the A's are the, the, the horizontal lines. Okay, let me just push them far away so we don't have any confusion. A, this is 2A, this is 3A, this is 4A. Okay, now I think I'm all set up here. We know that the area of the second largest region, this one here, is divided into 4 regions, 1, 2, 3, 4. So the area of this part here is 225. The area of the shaded region is 225. But the shaded region is a trapezium. And the area of a trapezium, there's a formula for that. So its area is 1/2 the sum of the parallel sides multiplied by the height, or the distance between the parallel sides. And this is a well-known formula. The formula for a trapezium, the area, is half the sum of the parallel sides times the height. And then the parallel sides of the shaded area are 2A and 3A. That's the sum of the parallel sides. And the height between them is H. So you get 5A. So this is 5AH over 2. 5A over 2 times H. And we know that this is 225. We are given that the shaded area. So 5AH over 2 is 225. Right. So that gives you an idea. It tells you what AH is. Therefore, AH is 2 times 2 to 5 divided by 5. Cross multiply, divided by 5, and that gives you 90. 450 divided by 5 is 90. Now, what is the area of the triangle ABC? The triangle, the whole triangle, the formula for the area of a triangle is half base. The base is 4A times the height, and the height is 4H. Right? 4 H's, 4A. So that is 8AH. 4 times 4 is 16 divided by 2 is 8. But we know that AH is 90. So this is 8 times 90. So it's 720. And we'll have to say square units. Every time you have an area, you have to say it's square units. All right. And the lengths of these are all units. Okay, so the answer to this problem is 720. But you can see, right at the end there, you got that the area is 720. So we were on the right track. That now takes us to problem number 22. There are 25 problems in the second round paper. Quite a lot of problems. I think they give you 4 hours. But even so, it can be quite difficult to complete. So it says here that a book contains 30 stories, each starting on a new page. Now, the first page will be 1 in a book. Then you turn it around, and then you get the 2 on the other side, and 3 opposite it, and so on. So if you open up a book, if this is page n, this is page n plus 1. So you must just remember that. I think you might have to use that. I'm not sure. Okay, so the length of the stories, okay, it's got 30 stories. Are 1 to up to 30. In other words, each story has got different lengths. One of the stories has got length 1, another one has got length 2 pages. They're 2 pages long. And another has got 3 pages long, and so on. And one of them has got 30 pages long. So all the different stories have got different page lengths. Okay, the first story starts on the first page. Let's just call it story 1. Starts on the first page. And what is the largest number of stories that can start on an odd numbered page? So you want a story to start on an odd number. So the first story starts in an odd number page, page 1. How many other stories start with an odd numbered page? All right, now you got the stories have got lengths 2, 4, 1, 2, 3, 4, and so on. Now, if you want the largest number of stories that starts an odd number of page, let's put all those which start on an even number. So let's make story 2. That it'll start on page 2. Okay, so the second story, because there's only one page, this first story is. Second page starts on 2. Now let me finish all the even ones. Story 3, So you got the problems, the stories are, half of them have got are 2 pages long. Well, the even pages, 6 up to 28. And then another, so let's exhaust all the even pages so we keep track. So story 3, suppose it starts on the even page. Story 3, how many of you got 14 stories start on the even page. I'm going to put all those stories, 14 stories, next to each other, so I know I'll get rid of all the evens. I want the largest number of stories that can start on the odd number of pages. The first one is, but now what I'm going to do is I'm going to put all the even number page. Let's call this even. Story 3, even. In other words, I'm going to put these inside here. I can put, for instance, I can put the story with 2 pages here, and then the next page, there will be 2 and 3. The next page will start with 4. That's an even start. Okay, this is the start. The story starts. The starting page will be at page 2. The starting page is even, and so on. And then they say the first story, yeah. Each starting on a new page, yeah. So we need to know that as well. So it goes to story 2, story 3, story 4, and you go up to story 14. I'm sorry, story 28. 2, 4, 6. And that also starts with even, because each one I'm adding an even number to the previous one. I must come to even. And then, let's make it story 30. That's the last even number, 30 stories. Okay, and now I've finished all the even ones. One is already there, so let's go to the story with 3 pages. We'll call it story 2. Okay, let me just get this thing right. I'm going to put, when I say story 1, it means the story which has got 1 page. Story 2, the story which has got 2 pages. Then I'm going to put the even one here. Story 4, story 6, and go up to story 30. So I've got all the even stories together with story 1. And now let's do story 3. And then story 5, all the way up to story 29. Now you'll notice that you're starting with even, this will finish at an even, and now the story 3 will start at an odd, because it's got 3 pages, you see. So the 30th story with 30 pages will finish in even, and if you add 3 to it, it's going to start at odd. Now the story 5, you're going to add an odd number to this, so this becomes even, you see. You're going to add an odd number to this, and then you have another odd number, story 6. I'm sorry, 7. I'm going to add an odd number to even, and all the way up to story 29. So let's see. So you have the story 3. So story 1, stories that start with the odd numbered page. Stories. Sorry. Stories that start on an odd numbered page. Okay, firstly, one certainly qualifies. All these are even. Then you got story 30, and then I said 3. Story 3. Story 3, I got even plus an odd. But now the next one, story 5, doesn't qualify. Because now I got odd plus 3. Odd plus 5. And that'll be even. See? But the next one will be odd. So you got 3, 5 doesn't work. 7 works. So you have to keep increasing this by 4. 7, 4, 11. It goes even, odd, even, odd. 15, 19, 23, 27. Right. So all these will be odd, and the rest will be even. So you got 8. But this gives you a very few odd. I've got too many evens. So I'll have to reconstruct this thing. I must try to get as many odds as possible. The largest number of stories that start with odd number. Because this gives me only 9 stories that start with an odd number. So can't I make all these odd here? Okay. So if I put story 2, oh yes. So what I can do is I can start with 1, but I must add 2 pages to this, to 1, to get page. This will be odd, you see. Sorry. Just getting right. So I can't put the even stories. Yeah, that's fine. But I'll have to put an even number of stories here. But then you got page 1 has got a 1-page story. Page 2 and 3, page 2 starts with this is the 2-page story. And this is a 2-page story. It ends at 3. So the 3-page story. Okay, why don't I put the 3-page story here? 1, and then put the 3-page story here. So that 3-page story will end at page 4, and the 5-page story will start at page 5. So this will be odd. And then this starts at an odd number, but this is a 5-page story. So okay, I've got the answer here. I'm going to rely on this. Sorry about this. So this is what I do. Okay, if you can see it, you see, we start by saying the first story begins on page 1. If you look at the line 2 here, an odd number. Then place the 2-page story there. Or on page 1, you don't place the 1-page story. You place the 2-page story at 1. That was my mistake. So this is a 2-page story. And then the this will take pages 1 and 2. And page 3, which is the odd number page, I place a 4-page story there, right? And that will make the next story to start at an odd number and put the 6-page story. So you put all the evens like this. The ones represent here page number 0 for even and 1 for odd. So all these become odd. See, so when you come to the 30th one, you put the 30-page story here. So we finished all the evens, and now the next one after 30, you place the 1-page story. And as I said, now when you add 1 plus 3, that becomes even. And so it becomes alternating like this. So you can think about this thing. But the important thing is you start with a 2-page story at page 1. The first story, I read that as the 1-page story, which was wrong. The first story begins with 1. So the story that we have chosen is a 2-page story. And then after that, you put only the even ones until you exhaust it. And when that happens, you get all the pages, all the stories start on an odd number page. Then after that, now you go to the 1-page story. So when you finish off the 30-page story, this will start on an odd number. This one starts an odd number, but it'll finish off an even number. So the next one will start an odd number, and that one I put a 1-page story here now. Right? I finished all the even ones. So that's also start odd number. But now I have to put only left with odd numbers pages now. So the 3-page story will finish off at an even number. 1 plus 3 is even. And the 5-page story will be will finish off at 9. So that's odd, like that. So you keep going on. Okay, so if you look at all the ones, those are all odds. You count there are 23. That's the maximum number obtainable. That's quite a tricky problem, but I think if you study this, you will see. The idea is to maximize the ones. Right? You want to get as many odd number starts as possible. I have to confess that it took me a long time to even understand what this question is. So don't feel too bad if you didn't understand it, but go and check it out again. Okay, now we got on to problem 23. Problem 23 says the following. A point P inside triangle ABC. Take a triangle. So the point P is inside this triangle. Let's just name this triangle properly first. This is A, B, C, and P is some point inside. And from this point P, perpendiculars are drawn to the sides. Okay, so from P, I'm going to draw perpendiculars. There'll be 3 perpendiculars. Another one. Okay, let me just indicate that they are perpendiculars. You need only put one 90 degrees. You don't have to put both. The other one is automatically 90 degrees. Okay. Meeting the points BC and D, respectively, is in that order. So BCCAAB, BCCAAB, like that. Now BD is equal to 8. So this is 8. DC is 14. CE is 13. AF is 2 root 30. That's AF, and FB is 6. You can see this is left out here, AE. And that's the question. The question is to find AE. All right, I gave this thing a lot of thought, and eventually I realized that you have to use Pythagoras. I wonder why. All right. So I noticed that I got 6 and 8 here. So let's call these heights. We'll call them A and B and C. Now we don't know what those distances are, but if I join the vertices of the triangle, let me just join this one here. Then I can get an equation involving A and B. Right? What is the equation? Because this becomes the hypotenuse, you see. You got a common hypotenuse for two right angle triangles. So what you have here is that A squared plus 6, A squared plus 36, A squared plus 36, sum of two sides, the squares of the sides, is equal to this one here. I'm not going to give this any name, but I know that it's a square of this, and the square of this, if you go to the other triangle, will be B squared plus 64. All right, let's give it a name. Let's call this X here. All right, so now that is from this picture here. And likewise, if I join that, then I've got B squared plus 196. 14 squared is 196. B squared plus 14 squared is equal to this diagonal squared. The diagonal squared is equal to A squared plus 169. 13 squared is 169. And likewise now, if you look at this picture here, you'll get X squared plus C squared plus X squared. If I join this line here, then you got, this is C. C squared plus X squared is that line squared, and that is equal to A squared is equal to the hypotenuse of the other triangle, A squared. Now when you square this, you get 120. 4 times 30. Okay, so now you've got three equations with three unknowns, so you should be able to calculate. Well, actually 4 unknowns. You got X squared here. All right, so this is supposed to be C squared plus 169. Sorry. This thing here is C. C squared plus 169. Okay, now what is x squared? X squared is equal to, I need to find this. This is equal to a squared minus c squared plus 120. I need to find x squared, so I need to find a squared minus c squared. So what is a squared minus c squared? Well, a squared minus c squared, a squared according to this is b squared plus 64 minus 36. That's a squared. A squared is b squared plus 64 minus 36 minus c squared. From the other equation, c squared is b squared plus 196 minus 169. Okay? Because c squared, I've got a minus sign in front, c squared is equal to b squared minus plus 196 minus 169. Now you'll notice when I remove the brackets here, the b squares cancel out. So you have 64 minus 36 is 28 minus, and here you have b squared minus b squared cancelled, and you got 196 minus 169, that's 27, but I've got a minus sign in front, so it's minus 27. No, that's actually 1. Okay, so a squared minus c squared is 28 minus 27 is 1. And so x squared now is equal to 1 plus 120. Oh, that's very nice, because this is 121. So x is 11, which is the answer. Nice problem. Well, if you know the 3 heights from the triangle, but you have to observe, the strategy is to see that you've got a common hypotenuse to 2 right angle triangles, and therefore you can get equations. You get 3 equations because there are 3 pairs of right angle triangles. So that takes care of this problem. Oh, yeah, and you can see AE is equal to 11 in this diagram. Okay, we go on to problem 24. So we're almost there. I didn't give myself enough space to do my calculations. Okay, let's see what is it saying here. The sequence T1, T2, T3 satisfies. Now this is Tn plus 1. In other words, each term, Tn, this is the n plus 1th term, and Tn is the nth term. So these are consecutive terms. And read this as consecutive terms. That means this one is just before this. So each term is a half of the term just before it. If Tn is even, okay, so you want this, if this is even, then you take half of it, so you get a nice integer. But if Tn happens to be odd, that's the other case, then what you do is you multiply by 3 and add 1 to it. So you can expect this to be an even number, because Tn, if it's odd, the 3 times an odd is odd. If you add 1 to it, that becomes even. So this thing becomes even. All right. So let's start here. The first 4 terms are 6, 3, 10, and 5. I'm going to write them down. 6, 3. Let's see why. They say each term, like this one here, is equal to, if the previous one is odd, there's a rule. If it's even, there's a rule. Now the previous one is even. That's your Tn. Right? Previous one is even. So the next term is half of that. So that's how, well, Tn is even. So the next term will be half of this 3. Now this term is odd. So the next term will be 3 times that plus 1. So it's 3 times 3 is 9 plus 1, which is 10, right? Now this is even. So the next one will be 5. Okay, so now when you add, let's just go on. They give you the first 4 terms, and they want to know what the 100th term is. So you need to see whether there's a pattern which is coming on. You've got 6, 3, 10, and 5. Doesn't seem to be any pattern here. Okay, now this is odd. 5 3 is 15 plus 1 is 16. Okay, so you come to that. That's the next term. Because that's odd, you make that rule. This is even, halve it, even, halve it, even, halve it, even, halve it, right? Now you come to an odd. So the next term will be 3 times this plus 1, which is 4. Now this becomes halve it. Oh, so you come back to 1 now. So the next term again is 1 times 3 plus 1, which is 4. Halve it, halve it. So this 4, 2, 1 keeps repeating. So you want to know what is the 100th term. Okay. So you got 1, 2, 3, 4, 5, 6. These terms here are all, there's no pattern in this. So this is the 7th term. This is T7, T8, T9, T10, T11, T12, T13, T14, T15. But I just want to see, you see, I got 7, 8, 9, and you got 10, 11, 12. So let's just isolate the multiples of 3. So you got T9 is 1. T12 is also 1. So this is equal to 1. T15 is 1. So if you keep going up like that, all the bases, the subscripts, which are multiples of 3, now which is the nearest multiple of 3 to 100? Because the question is to find the 100th term. This one here. So the question is, what is T100? Now, this is 3 times 3, 3 times 4, 3 times 5. This has to be 1 as well, because this is also a multiple of 3. So T99 is 1. So this is T99. Now that's an odd number. So the 100th term will be multiply this by 3 and add 1 to it, and you get 4. So that's the answer. The answer is that the 100th term is 4. Because T99 was odd, you see. Because the sequence just becomes, it's a repetitive, 4 to 1, 4 to 1, 4 to 1. So it's highly predictable. Okay, so the answer is 4. Okay, so you can see, I think I solved it in the same way. Okay, so that takes us to problem 25. Okay, the last one. Okay, for how many positive integers n are n and 4n plus 2, 1, 1, 2 both perfect squares? Okay, I think I'm going to need another page here because this is, don't have enough space here. Oh, anyway, let's try to see what we can do. Let's separate. Maybe I better create something here too. Okay. So you have n plus 112 is a perfect square. So n plus 2012, 2112 is a perfect square. Let's call it a. So a is an integer, it's a perfect square. You've got 4n plus 2112 is also a perfect square. Now, I'm going to call this is obviously even. So this is an even perfect square. So it has to be the square of an even number. I'm going to call that 2b. Because it has to be a multiple of 4, you can see. So the square is even. The square of an odd number is odd. So this is a square of an even number. Okay, so now that way I can cancel the 4s. So the question is, we need to find n. To find n, you have to find a. Once you find a, then you can find all the n's. Or you can find b, then you can find all the n's. Okay, let's make this thing 4b squared. So you have, if you divide throughout by 4, you have n plus 528. If you divide this by 4, you get 528. Divide this by 4, you get b squared. All right, so now you've got these two equations. Let me just remove this middle equation for the moment. No, I can't remove it. I need to know that this is 2b squared. Okay, so if you regard this as equation 1, equation 2, now I can eliminate the n by subtracting. So let's look at this, 1 minus 2, equation 1 minus 2, n minus n will cancel off, and you get 2, 1, 1, 2, minus 528 is equal to a squared minus b squared. A squared minus b squared. All right. Now this is, let's put this in properly, this is a squared. A squared minus b squared is a minus b into a plus b. So the a minus b into a plus b is, when you simplify this, you get 1584. Right, 21 minus 5 is 16, so you come 15, and 16 away from 100 is 1584. So now you got the product of two numbers is 1584, right? Now, notice that let's call this x, call this y. So you got that x times y is 1584. So I need to factorize 1584 to get to the solution, where x is a minus b and y is a plus b. So x plus y, when you add these two, you get 2a. And here I've got y minus, x minus y will be a negative. Let me make that y minus x. If I subtract this from that, that gives you 2b. Each time I give a name, we have to just keep track, otherwise you can get lost. I actually need to find a and b, right? If I find a, then I've got the solution. I can solve for n. So let's just see that what is A? A is x plus y over 2. And B is y minus x over 2. But the point is that x and y are x plus y is even. So if x plus y is even, the two integers, when are sum of two integers even? It's 2a, you see? So that's even. The sum of two integers is even, provided that both are odd or both are even. X and y are both odd. X and y can't be both odd because the product of two odd numbers can't be 1584, right? Not possible, since xy is 1584. So therefore, x and y are both even. Both even factors of 1584. Okay, now this is where I am at the moment. So you got 1584. We need to factorize this into two even factors to get xy. So let's look at xy. Right, I want to multiply two even numbers to get to xy. So you can take x is 2, and the other one is 792. Okay, but now we can't take 3 because we want both to be even. But 4 certainly is a candidate because you got 1584 and 4 goes into that. So it's 4 times 396. 6 also goes into this, 6 times 264. 8 goes into this. Hey, lots of all these even numbers go into it. 8 times 198. And 10, of course, doesn't go, but 12 does. 12 times 132. 14 doesn't go into it, but 16 does. Oh, but 16, you'll have 16 times 99. That doesn't work. You want both of them to be odd, even. So 16 doesn't work. I just have to keep track of that 1699. We have to eliminate it. So the next one is 18. 18 goes into both of them. Because you see 1, 5, 6, and 8, 14, 4 is 18. So multiple of 9 is also multiple of 2. So 18 goes into this. When you see what 18 goes into this, divide it, you get 18 times 88. All right. Then the next one is 18, 20, 22. 22 goes into both of them. 22 times 72, I think. 22 to 72. You also have 24 times 66. And then you try all the other ones, 24, 26, 28, 30, 32. 33 goes into it, but that's an odd number. So the next one will be 36, I think. 36 times 44. And I think this is going to be the last one. Okay, then after that, you're going to get the same pair. 44, and 36, and so on. So you got 1, 2, let's say how many positive integers? 3, 4, 5, 6, 7, 8, 9. It seems to be that all 9 will give you solutions. Okay. And this is XY. Now let's have a look at, let's go back and retrieve the A and B. I'm going to just create some space here. But to retrieve the A and B, I must use this formula here. So A is x plus y over 2. So that means A is, you just add these two, x plus y, and divide by 2. So you get 397. And you add these two, you get 400. That's 200. Add these two and divide by 2, 134. Okay, I'm not going to go there. It's so boring. So 36 and 44 is 80. Divided by 2 is 40. So we are saying a possible value for A is 40. But you have to be a little bit careful here because n is a positive integer. So you can't put any a squared here. You see, this implies that a squared is n plus 2112. N is a positive integer. So this is greater than, a squared is 2112, is greater than 2012. All right. So a equals 40 doesn't work. 40 doesn't work because you got 1600 is not greater than. So this has to be out. Right? Reason being that a squared, so just note that a squared must be greater than 2112. Now what's the other a? The one just before this is 24 plus, this 36 plus 44, 80 over 2. That's how I got the 40. This one here is 90 over 2, which is 45. If you take 45, the one just before this is 45. 45 squared is 2025. And that doesn't qualify as well, because you want a squared to be. So even 45 is out. But all the other ones are bigger, right? So instead of 9 solutions, we saw that there were 9 here. You have to eliminate the last 2. Therefore, there are 7 solutions. So the answer is, it's quite a demanding question, this. 7 solutions. Let's try one of the A's just to check. Let's take the one, say 2272. So let's try xy equals 2272. This implies that A, I'm not worried about the B. I just want to know how many solutions there are. So A is equal to x plus y over 2. That's 94 divided by 2, so that's 47. All right. So let's try 47 squared. N plus 2112 is equal to 47 squared. That's 2209. Right? That's N. And therefore N is equal to 2209 minus 2112. What is 2209? There's a 7 here, there's a 9. Yeah, 97. So 97 plus this gives you 2209. So n is 97. So if n is 97, you want 4n plus. So 4n plus 2112. 97 is 388 plus 2112. Ah, that's 2,500. And that's beautiful. That's 50 squared. See? So 4n plus 2112 is a perfect square. Okay, so I just tried one of them. A equals 47 and B equal to 4b squared. So B is 25. Yeah. So we're interested in the value of n. So n is actually 2,209. No, 97. You see, you wouldn't have been able to figure this thing out. That when you put n equals 97, then when you add this, it becomes a perfect square, and it's a perfect square for this. So this mathematics is very powerful. See, it's not gives you just not one, but it gives you a whole lot. All you have to do is to just add these and divide by 2, and you'll get all the possible. This one here was gave you when you add these two, divide by 2, you get 47, and then I substituted them because a squared is n plus 2112. Actually, what you need is n. N is equal to a squared minus 2112. So you take all these numbers and subtract 2112, and that will be your n. Okay. Sorry, hopefully you'll be able to read what I've got here. And so I think I've got a different solution to mine, but it's somewhat similar. And that's one page. So we did get 7. We had 9, and we had to remove 2, and we got 7 solutions. But now this is all written in great detail. So please look at that and see how you can solve this problem. But there is a very good way of actually solving this equation. X plus a squared equals b squared. Solve for x. Or let's call it n. Solve for x. Solve for n. Now I've got a whole section in my book on this particular problem. The book is called 1000 Mathematics Olympiad Problems. I think. If you go into the SAMF website, samf.ac.za, you'll be able to see this book. It's not free, you have to buy it. But it's got 1,000 problems, and they have all various levels, and with the solutions and with the notes and everything. And one lesson tells you how to solve this problem here. And I'll tell you what it is. The idea is factorize n. Solve n. Factorize n so that both of them have the same parity, so that x and y are both odd or both are even. You call that parity. Parity is the evenness or the oddness of a number, right? And then the A, immediately you can say what A is. A is, we can make it X less than or equal to Y. One of these is bigger. So A is Y minus X over 2, and B is Y plus X over 2. That tells you the solution for this. You can get all the solutions like this, you see? So the idea is to take your n, factorize it, and then take the larger minus the small and divide by 2. They got the same parity. So if both of them are even, the top part will be even. So this becomes an integer. And if both of them are odd, then the difference will be even, and it becomes an integer again. So this way you'll get A and B are integers. Like for instance, suppose I want to know, find all A such that let's take a number, say 48 plus A squared is equal to B squared. Right. And to solve this now, you just take all the possible factorizations of 48, which is both must be even or both must be odd. So you'll get 2 times 24, both even. You can't take 3 and 16 because it doesn't work, right? But you can have 4 times 12, or you can have 6 times 8. Right? And that's it. We want X to be smaller than Y. And then, now these are X's and Y's, so A is equal to 24 minus 2 over 2, so that's 11. Or, here I can say it's going to be 4. It's 12 minus 4 is 8, 4. And here I can have 1. 8 minus 6 is 2 divided by, or 1. So now you put 48. So you get 11 squared, or 48 plus 4 squared. These are the values of A. Or 48 plus 1 squared. And we are saying that all these are perfect squares. When you work this thing out, you get 169. There it is. That's a perfect square. 48 plus 16 is 64. That's a perfect square. 48 plus 1 is 49. That's a perfect square. See, it's a very beautiful way of finding all the possible solutions to this. Which A's give you that this is a perfect square? So this is a very nice, short way of doing it. And I have to proudly say that this is my discovery. I don't think many people use this method, if there are any. Right, so guys, that brings to an end this problem or this paper. And okay, so enjoy the rest of the day or the rest of the evening.